Hello, ladies and gentlemen. So now that we have a handle on shortcuts for congruent triangles, it's time to go back to proofs. So we're going to be writing some proofs today. What this looks like in terms of proving triangles congruent now, okay? Now that we have a handle on those shortcuts, how do we tie this back into our idea of writing proofs? So recall when you wrote proofs and you were using those properties, justifications, what you were saying, essentially you had to have a reason in every diagram that justified your statement. Some helpful hints about triangle proofs are that you know your shortcuts, so that you know the side angle, side, because they are the end goals in proving triangles congruent. And that you also mark your picture with congruent marks as you write things in your proof. Those are my two helpful hints for this part of proof writing. So let's do a few examples here together. You need to draw the picture in your notes. The picture is a very big part of the proof. And you also need to write this given. And the goal is what we are trying to prove, okay? And we're going to go ahead and draw the statements and reasons together. There's nothing given to us. We're going to write this proof from scratch. But I think you'll find that triangle proofs or congruent triangle proofs are a little bit easier than the other proofs that we even wrote this year because you have a basic understanding of how triangles work in those shortcuts, okay? So let's go ahead and start this proof, of course. Now that you may have written the given and the proof there, go ahead and pause anytime you need to. Draw that picture, and then we're going to go ahead and run through how we go ahead proving these triangles congruent. So we're going to have two columns, statements and reasons. You can also label the reasons justifications if you want to. You can put a line down the middle, but you don't have to. But we're going to go ahead and, like always, start with our given. We have angle ABD is congruent to angle BDC, and we have angle ADB is congruent to angle DBC. So those are our first two steps. And for both of those, we're going to write the word given because it was given to us. And so now when we go over to the side, this is my helpful hint. We have some things written in our proof. We don't have any markings on our picture. We need to mark what was given to us as being congruent. So we have angle ABD, that's this angle up here, is congruent to BDC, that'd be this angle down here. And ADB, this one right here gets two slashes because he's congruent to DBC up here. So notice that the angle pairs have now been marked, keeping in mind that our goal is to try to prove these two triangles in this picture congruent. And you know the shortcuts that we can use. Now, when you look at this picture, would you say those two triangles are congruent? You might. You might, because we've already talked through the reasons why they would be. Now it's time to formalize that in a proof. So you might be seeing, hey, you know what? Those two triangles share this common side, BD. And so normally we would visualize some little slashes there or write them. We should say that in our proof then. We should say that segment BD is congruent to itself, BD. And what property says that something is congruent to itself? That's the reflexive property. So we needed that property and to have an understanding of it because now we especially see that being applied when we have congruent triangles. That BD is congruent to itself, their two triangles are sharing it essentially. So now when we look at what's marked in our picture, do we have our congruent triangles there? Are they congruent? Is there a shortcut that we see? Yes, we see angle, side, angle in both triangles. So I know that my triangles are congruent now because I see angle, side, angle. So my last step then in this proof is going to say that I see angle, side, angle, and that means that the two triangles, ADB is congruent to triangle CBD. Those two triangles are congruent because I see that shortcut. So that's the end of that proof. We basically are doing what we would do in our mind when we look to see if triangles are congruent, but we're formalizing it in writing a proof. So let's look at a second example. Here we have one where we're given that AC bisects BD. This should be a D up here, so if you want to draw that in your picture. And then angle B is congruent to angle D, and we're going to prove these two triangles are congruent. So again, statements and reasons. Here we go. First step, always write that given. So we have AC bisects DD. And we have another piece of given, angle B is congruent to angle D. And again, both of those are given. So again, after we write our given, our next step will be to go to our picture and actually mark what's been given to us. Mark the things that are congruent as said in the given. Okay, so the first piece of given, though, you guys, says that segment AC bisects BD. So AC cuts BD in half. So BD is cut in half. From B up here, down here, to D up here, this piece is cut in half. That's what it means to be bisected. Now, when that happens, yes, you have some congruent pieces. You would have DO here and OB would be congruent to each other. Now, we never said that formally in this proof, so we'll take a moment and do that. DO is congruent to OB because definition of bisects. That's what it means to bisect. It told us that BD was being bisected. It was cut in half. So definition of bisector, definition of bisects, whatever you want to write there, but we saw that word and we know what it meant. Okay? Now we did something with this piece of given. Now what about the second piece of given? Angle B congruent to angle D. We didn't mark that, so let's go ahead and mark that. And that was just because it was given to us. Is there anything else in our picture that we know for certain would be congruent? Well, yeah, these are vertical angles right here, right? So we're going to go ahead and write that angle DOA is congruent to angle COB because vertical angles are congruent. They're vertical angles, so that means they're congruent. All right, so now looking at my picture, do we have congruent triangles yet, or is there more that we need to look for? Well, it looks like we have congruent triangles. What shortcut do we see there? We see angle, side, angle. So because we see that, we know our proof is done. We can say triangle DAO is congruent to triangle BCO because we see angle, side, angle. Okay, so let's look at a third example here. This one has the word midpoint in it. So we're given some information. Some information looks like it's marked on the picture, some isn't. And we're going to go ahead and once again and write our statements and our reasons to prove these two triangles congruent. So given AB is congruent to CB, and also given D is the midpoint of AC. You'll see me abbreviate a little bit there. Steps 1 and 2, once more, both given. So starting with our given information, let's look at our picture. Are they marked? AB congruent to CB? Yep, it was marked already. That's nice. So that's there. We also know D is the midpoint of AC. So D is a midpoint. Now, if D is the midpoint, what does that exactly mean? Well, it means AD and DC would be congruent. We haven't said that in the proof specifically, so we need to write a step saying that. AD would be congruent to DC because definition of midpoint. That's what it means to be in the middle. Silly, right? You have congruent segments on either side. So now that we have that marked, now we look at our triangle picture and go, is there anything else like vertical angle, sharing a side, alternate interior, alternate exterior, anything like that that we can pick out of this picture that might help us get to those congruent triangles? And you should be seeing that, yep, once again, DB is shared by both triangles, so we would say DB is congruent to DB because of the reflexive property. And now we look at our picture one more time, say, is there anything else? Well, we don't need anything else because we see side, side, side is marked for those triangles. And when that happens, that means your proof is done. We have triangle ABD congruent to triangle CBD by the side, side, side postulate. Okay, so this is the idea for making congruent triangles. I have one more example here, and then we should be good to go. So let's do our last example. This one includes some parallel lines. So we are given that we have AB parallel to CD and AB is congruent to CD. So we'll go ahead and write statements. Whoa, reasons. There we go. So given information, AB is parallel to CD, and AB is also congruent to CD. And we are given those two pieces of information. So now when we look at our picture, is there anything else that we can say? It looks like those two things are already marked. We have congruent marked on, and we also have the idea of being parallel marked with little arrows here. So there's nothing else that we have to add in there in terms of markings based on our given information. But is there anything else that we could add? Let's start with this idea of being parallel. When you have parallel lines, or segments in this case, you have some congruent angles. So let's think about, what about this angle down here, angle DCB? Which angle would that be congruent to? This one up here, because they would be alternate interior angles. So we would say angle BCD is congruent to angle ABC because they are alternate interior angles. Okay, so with that in mind, we could pick the other pair. We could do that, but I don't think we need to as long as we see that they're sharing this side right here of BC. So when they're sharing that side, we would say BC is congruent to BC by the reflexive property. And if I look now at what we have marked in the triangles, we have a side, we have an angle, and we have another side, so the angle's in between the two sides. We say we have side, angle, side, and we know that the two triangles are in fact congruent. So ABC is congruent to triangle DCB. Okay, so that's an idea of congruent triangle proofs. I want to thank you for taking good notes.